Hello viewers, in today's class we are going to discuss yet another problem and concept from three-dimensional geometry, right? So here we have a plane and a line, right? So let us take the problem which says that find the equation of the plane passing through the point 1 comma minus 2 comma 1 and perpendicular to the line joining the points A 3 2 1 and B 1 4 2, right? So here we have a plane, right? Suppose this is the plane and we have a line, say this is the line joining the point A and B, and the coordinates of the point A are 3 2 1 and B are 1 4 2, right? And this plane is perpendicular to this line, right? That is the line AB, right? So now here the concept is that if we take the perpendicular or the normal to this plane, right? Suppose let us denote this plane by P, and if we take the normal vector that is vector n, then we see that this normal vector is parallel to the line, right? See here we are given that we have to find the equation of the plane passing through the point, say this is the point, say Q, right? And the coordinates of this point are 1 minus 2 and 1, right? And this plane is perpendicular to the line joining these 2 points, right? And let us take this line as L, right? And this line L is perpendicular to this plane P, and this is the normal vector to the plane P. So what we conclude, that plane is perpendicular to this line, but this is the normal to this plane, hence these two vectors are parallel, right? So when the plane is perpendicular to the line, then the normal must be parallel to this line, right? And from this we conclude that parallel vectors have either equal direction ratios or proportional direction ratios. Now let us first write the equation of the line AB, right? And we know that here we are given 2 points. Say this point is x1 y1 z1, this point is x2 y2 z2. Then the equation of a line passing through 2 points is given by x minus x1 over x2 minus x1, y minus y1 over y2 minus y1, and z minus z1 over z2 minus z1. So we can write x minus 3 over 1 minus 3, then we have y minus 2, and we have 4 minus 2, and then we have z minus 1 over 2 minus 1, right? So we can write it as x minus 3 over minus 2, y minus 2 over 2, and z minus 1 over 1, right? So now this is the equation of the line AB, right? And from this equation we see that the direction ratios of the line AB are minus 2, 2 and 1, right? And here we have seen that this normal vector to this plane P is parallel to the given line, right? Because the plane is perpendicular to the given line, right? So here this vector is parallel to the line, and we know that if we have two parallel vectors, then either their direction cosines are equal or proportional. So therefore we conclude that the drs of the normal vector may also be taken as minus 2, 2 and 1, right? So now we have obtained the direction ratios of the normal vector, and we are given a point on the plane, and we know that equation of any plane passing through a point, say x1, y1, z1, is given by a x minus x1 plus b y minus y1 plus c z minus z1 equal to 0, right? And a, b, c are the direction ratios of this normal vector, which are given by -2 to 1. So we can take a, b, c as -2, 2 and 1, right? And x1, y1, z1 is this point, that is 1, -2 and 1, right? So substituting the values, so here we have -2x minus 1, then we have b is 2y minus y1, so we have y plus 2, because here we have -2, and then we have c is 1 and z minus 1 equal to 0. Now we can simplify it, so we have -2x plus 2 plus 2y plus 4 plus z minus 1 is equal to 0, and this is -2x plus 2y plus z, and 4 plus 2 6 minus 1, that is 5, right? And if we multiply throughout by -1, we can write 2x minus 2y minus z, minus 5 is equal to 0. So this is the Cartesian equation of this plane P, right? And we can also write the vector form of this equation of plane, that is r dot, here we have the normal vector n as 2i cap minus 2j cap and minus k cap, and -5 is equal to 0. So this is the vector form of this plane, right? Now we can also write this equation as vector r dot 2y cap minus 2j cap minus k cap is equal to 5, right? And if we divide both sides by 3, right, because see, the square root of 2 square plus minus 2 square plus minus 1 square is given by 4 plus 4 plus 1, that is 9, and this is 3. So if we divide both sides by 3, then we have 2i cap minus 2j cap minus k cap over 3, and this is 5 over 3, and this is a unit vector, right? This is the unit vector, so we can write it as vector r dot n cap is equal to 5 over 3, right? So this is another form of the vector equation of this plane P, right?